So there is this sample data store, right? So we know how to connect our data now, correct? So let's do that, or let me do it from the scratch itself, so that we we know what are we doing. So what we will do is we will be blending. While we were doing joins, what we did is we connected to data over here. We connected an Excel and we brought this table over here. We got this data source and then we dragged in for the join to happen. But then now we will not do that. What we will do is we will do a we will do a blend. So let's go over here and let's see how is data getting blended. So this is the orders data set. Among the sample superstore data set, this is the orders tab in which we have these these dimensions and measurements. Now let me go back to this, and now let me we have seen how we view data, right? So let me view the data for people, and let's see that if I want to have a mix between this between orders and people, do we have enough data that will help me? So I can see that in people I have region and regional manager being two dimensions present in there. So let's see if we have something similar to that. So I can see that we have a region being one of the common columns between the two, right? So let's see how we can blend these two data sources, and like these are different tables altogether. So let's see how we can blend these two. So that's my orders. And now if I go back to the data source, and if I go over here and if I do a new data source, oh yeah, new data source, Excel, same sample data store, and now I'll drag in people. Okay, so now you see that we have the people data set, which is over here. Now let's go back to the sheet. Now when I come to the sheet, what I see is both the tables have been added in here, right? Both the tables are added. When I go to this, I see this. When I go to this, I see this. And we have seen that we have a common column of region which is present in there. So we know that, okay, we can have some kind of a relation, and this relation is being decided by Tableau. So data blend is not that flexible like joins, because joins have left, right, and they have the unique things coming in and all those factors coming up. But blend is basically happening only based on one one column being being common between the two. So there is no such. That's why blending is something which is not a very what to say, refined form of harmonization. It is a very crude form of harmonization. You have to be dead sure that both the columns have all the things in order to get your data together. But blending is not not much recommended between people who work with data, because it is like it is heavily prone to errors, and it'll throw up errors. And you have to do a robust data quality QA and all those things in order to do. So no worries. Let's not let's not go into that. Or rather, let me go into that and tell you these things, because uh, try to avoid data blending whenever possible. But then this is a feature of Tableau and we need to be aware of it, so definitely yes. So now based on a common column we are doing this. So this is a feature that, and Tableau recognizes these things automatically. So let's see a very short example about this. That orders, let me pull in say, what should be sub, let me pull in order ID. No, on mail, let's put in date. We have the date, right? Order date. Yeah, let me pull order date to columns, and let me pull sales to rows. Okay, I see this happening. Now region is coming from people, right? So let me pull region into colors. So you see, what happens over here is, data gets blended, and we have the regions wise year and sales, whereby year and sales is coming from this table, and excuse me, and colors, the definition of these, uh, of the, or the bifurcation of the data is happening from the region table that is coming from the people's thing. Now, if you can see, you will see that one data source is in blue, and the other data source, as soon as I use from it, is in orange. See over here. So that, what does that mean? That means that, the orders data set is the primary data set which was being worked on, and people data set is the secondary data set which is being used to manipulate whatever we are doing from the primary data set. So always the primary data set operations will come in blue, and the secondary operations, ticks will come in orange. Secondly, this orange also signifies that there is a blend that is happening, and there is a data blending that has happened. One more thing that tells that, this is the column which is helping the blending, is the symbol over here. So it is telling me stop using region as linking field. So the region is the linking field between the two data sources, right? So if I click on this click button, what it is telling is, so based on it is connecting. So if you click on that, it will stop linking the two sheets based on this column, and it will stop. So that's data blending. So data blending is basically, not much common. I'm not sure how many of you, if you have worked on Tableau before, or if you have seen something. So you know if you have seen people working on data, in a robust data engineering field, data blending is a very crude form of joining stuffs together, but then, no harm in learning. So let's do that. Okay. So what we can so we have now seen that how we do the data blending. Any questions, guys?
No, Will.
No.
I'll consider to be a no. Okay, then let me remove this. Now, the next topic that we will discuss is calculations, and you will see that there are always calculations are something that we are always concerned about, and how we do the calculations, and why do we do the calculations, and how does calculations affect things. So let's look at calculations, how we do calculations, and what are the various types of calculation. I'll not teach you calculations like every single formula or anything, because that is very self-explanatory and you guys are smart enough to go ahead. If I show you where the formulas are, you can very well go and edit them and you can do so. But let me show you a story whereby, the different types of calculations come into play. Okay, so calculations come in various forms, namely, arithmetic calculations, string calculations. Basically, arithmetic calculations, string calculations are the common ones which are used. Then comes the logical calculations, whereby we use the logical functions and statements. And then what we will do is we will see uh, two more types of calculations that Tableau offers us, namely, table calculations and quick table calculations. So these are some of the calculations that we will have a look at, and we will see like how we can work towards that. Okay. So before that, let me bring in again this thing, the orders data, and let me go to the sheet. So if I want to, over here, first thing is, let me do something. Let me first show you how to take counts and distincts. So count and distinct count is basically, again, it's very self-explanatory, whereby if you have a dimension and if you use a count function, what it does, it gives you, how many elements of that dimension is present in there. And then count distinct basically gives you the unique number of things that are present in there. So let's see how count and count distinct works, or how they work related to the every, related to every dimension that is present in us. So let me do something. Let's say take state into the rows, and let me have sales in the columns. Okay, so now I have the states and their respective sales. Correct. Now, let's say tomorrow someone comes up and says that, the sales of these states are here, but I also want to know the count of distinct items in there. So what will you do? So that is your sales figure. Now, the distinct items, when they want to see anytime, like this is the count of items that we have. So what do you do in that case? So you'd use definitely your item means product names, so products, basically product names, like how much of product is present in all these areas or all these states. So when you want to do that, one way is to put functions and stuff. But then Tableau provides you with one more feature over here. So what you can do is you can go to this product name, right click. Now this click, I cannot show you the click, but I'm clicking right. Okay. So I'm doing a right click and I'm dragging it into the columns. So once I do that, see, normally if I drag a product name over here with left click, it will be as good as a dimension, right? See, it is coming as a dimension. But if I do a right click and pull it to columns, what happens? There are few aggregational functions that come up, namely minimum, maximum, count, count distinct, and attribute. Okay. So what do we need? We need count distinct all in this case. So, okay, let me show you what is the difference between count and count distinct. So let us have count. Yeah. And then let me pull this guy once more over here and have a count distinct. So you see what happens? 61 is 61, 26, 11. So that does mean that 20 among 26, 11 is unique and rest are duplicates. Okay, that's pretty self-explanatory, and this is something that I just wanted to make sure that you understand. And always you will find the distinct count to be less than or equal to the count. Okay, never will it be more. Of course, it won't be more. It can be less than or equal to this thing because this also has duplicates. Okay, so in this case, so now we have the distinct count of product name. I don't need count, so I'll just remove count over here. We have this. So what happens is aggregation functions. Once you have something, you just right click and you can take it up there, and you don't need to write a function, or you don't need to do these things. Similarly, aggregation functions are available when we right click on a measure as well, but that is some multiply, etc., etc. Clear? Now next is this, your stakeholder, he wants to see sales per item sold. So what is sales per item sold? He wants to see that, can you show me what is the sales per item sold um, calculation? So now this field is not present in here. So what you need to do is you need to calculate a field. Okay. So to get your calculated field options, there are two types of ways to get your calculated fields. One is above this entire data window, you will see view data, and then you will see a drop down. So you can go and click in your drop down, and you will see there is an option called create calculated field. Okay. The other way, to do is, you go to, say, anything, any dimension of measurement, do a right click, you will see a create, and from there as well you can do a create calculated field. So there are two ways in which you can get to the field, create calculated field, and you can use them. Now the only difference between the option is that, in case you are doing a create calculated field on your product ID or product name or region or whatever, Tableau knows that this person is specifically wanting to create a calculated field on region. Okay. So Tableau understands that this person wants to create a calculated field on the region, and the region is one of the dimensions that he is going to use in his calculation. So that's why if you pull in calculation, like, if you do a right click and do this, you will find that the dimension on which you had right clicked and created a calculated field, that automatically appears in here. On the other hand, if we see this over here, nothing comes up because this drop down wala field doesn't know that which dimension do you want to refer to. Okay, one more feature is this arrow. You will find this arrow, which is basically a small guide towards all the functions that are available in Tableau. Okay, and not only that, it also gives you a text beside. See, there's a text beside, performs a logical conjunction on two expressions. So, it gives you a very discrete, very, very, very small one-liner, and also examples. One-liner stuff for you that, what, this means this. Now, if you know that, you will understand and you can refer them. So that's basically it. Now, for us, what do we need to calculate? We need to calculate sales per item sold. Okay. So for that, what are the fields that we need? We definitely need sales, and items are products, so product names. So what do I need as a calculation? I need sum of sales divided by items sold. Items sold is number of items sold. So that does mean count of product name, right? Product is my items, and count of product will give me the number of items. So let me write a formula. Oh, okay. You can go over here and you can write this as well. Like, from here you will get the formula. So if you use sum, what will happen? Sum and the brackets will come. So what do I need to put over here? Sales. So sum of sales divided by count, right? So I can go over here and I can, if I know I can do this, else there is this referencing place, right? So if I do count, it will give me all the count related functions. Okay. So what I need is distinct count of product name. Okay. So I have distinct count of product name and the calculation seems to be valid. Let me apply and okay. Okay. So I have created, wait, where did I, calculation one, right? So I have created this, I've created this thing called, let me rename it as well, I thought I'll forget. This is sales per item sold. Okay, now sales per item sold comes over here. Okay, cool. Any doubts? Any doubts that come to your mind till now? No, right? I guess no. So now let's do something. Now that we have this coming up, now that we have this over here, what do? We now will replace the count of product name from here. Let me remove sales as well and let me put sales per item sold over here. Okay. Now you see, now once I've done it, it gives me what is the sales per item sold numbers are. So when you do that, what happens is, you will see that an aggregated thing comes beside this. You see this? So calculated fields come with an aggregate and their aggregations cannot be changed unless the native metrics where we native metrics are something that we change up. So whenever you create a calculated field using measures, there will be this AGG aggregation. So this aggregation will happen and you will see this aggregation happening um, in the text and this will come up when we have the two measures in a calculated manner. So that's how you write a formula, you create a calculated field and you use it. Okay, so clear. So that's basically my first arithmetic calculation that I did. Now let's look at string calculations maybe. So in string calculations, like what do we want? We want customer names, say beginning with S. Now we have a range of customers over here. Say suppose I put it. Now we have the customer names. Now from arithmetic calculations we are moving to string calculations. So we want to see the customer names beginning with S. Now say suppose you are a company who have a range of customer names and you are targeting the ones with an S to give them some kind of an offer. Okay. Now it will be difficult if you want to use a filter and then do, because say customer name in filters. Now you sit and do manually everything and you go like kachak kachak, you want to use it and you want to do it as a calculated field whereby you want to do all these things. This is going to be like uberly difficult for you, right? So rather than that, what do you do is, I'm sorry. Rather than that, what you can do is one thing is there which you can do is, oh, that didn't come to my mind earlier. One thing that you can do is you can put it in filter and you can use a wildcard, and you can use starts with S. Yeah, and then I guess you will do that. You can do that, uh, and with a condition even. So, but over here, as we are doing a calculated field and a more sustainable form of thing, so let's. So what we will do is we know that we will be modifying customer name. So what we will do is we will create a calculated field on customer name. So right click on customer name, create calculated field. Now we see that customer name automatically comes up. What is our criteria? That names that starts with S, correct? Now let's see what do we have as a formula. So we do see that we have a formula called starts with, correct? So let me use this formula starts with, and let me copy this and paste it over here, customer name. Now, what is the substring that I need to see? It is telling me starts with customer name. It starts with, like, whatever name it will fetch from there. And then it is asking for a substring. The substring is how it will, like, what will it fetch from this column that you are telling. So you need to define the starting letter, say S. Okay, then you apply and okay. Now, oh shoot, I didn't name this as well. This one was the one. Ah, this one. So now that you have the calculation ready with you, now you know that okay. If I do this now, what will happen after doing this kind of a calculation? Nothing but a Boolean value will come once you put this into the filters. Okay, so if you put it into filters, what will happen is a Boolean value pop-up comes up as an aggregation. Why? Because we have told them that if it is S, then let us know. So once that are S, this guy has referred to it as true, and once that are non-S, it has referred to it as false. Okay, now if I put calculation one in filters and then select true and apply, what I'll see, all the ones with the letter S comes up over here. So that's how you basically put this calculation over here, and once you use the true thing, what happens is all the names with S comes up. Okay, so Boolean, that's how you do a string calculation. Now let's do a date calculation, maybe, or let's do a logical calculation, then we'll look at a date calculation. So now, say suppose your manager comes to you and says that, you know what, can you please do a graph or a visual and tell me or highlight all the subcategories that are having a sale more than 1 lakh. So what will you do? You will have subcategory and you will have sales. And what has he told you? That if sales is more than 1 lakh, then it is high. So do highlight it over here, else low. Okay. Now you know that this is your subcategories and that's your sales figures. Now you need to highlight it. So what will you do? Again, you will go and write a calculate. Go to this, right click, calculated field, and over here, what will you do is you will write the, say suppose it, name it as sales target, and the formula being so we will use, as we are using logical functions. So what we will do, let me just remove this. So let me go over here. And do I have a if? We do have a if, right? So if, what is my first function that is there? Is sum of sales. Always remember, whenever you are using a measure in your formula, you have to use an aggregation. If you don't use an aggregation before it, you will get errors. Okay. So if sum of sales is greater than 1 lakh, so then what you do is you have to highlight it. So how will you highlight? You will say, suppose write it as high. Okay. Else low. And always the logical, whenever you're writing a logical if else, it always ends with an end. Once you do that, you will see that the calculation is valid. So now you can apply. Okay. And you see something called sales target has come up in your fields over here. Now what do? You pull this sales target into your colors, and you can see that we have a high and low populated over here, whereby everything that is more than 1 lakh, see all these bars are more than 1 lakh. Okay, are highlight, like, the ones which are highlighted, they're in blue, and the ones which are below 1 lakh, those things have come in green. Okay, and then you can, if you want to use your labels, then you can go ahead and you can show your labels from here. And this is your label appearance. Like, if you want to, you know use it, you can show it up. Okay, so that's how a logical condition works, whereby you are showing that, what is it um, that is affecting, these things, and what is it that is affecting, the low and highs. And you can venture out with, there are so many formulas in there, and whenever you get a requirement, whenever you get a chance, do look into it, and you can see uh, what all formulas are there, and you can explore it on the visuals. So that's about logical conditions. uh, Next comes the two important things, which are called grand totals, uh, grand totals and subtotals here, which are called quick table calculations and table calculations. So whatever doesn't come in your calculated field, like whatever doesn't come in quick table calculations, come in your calculations. Now, what are quick table calculations? Quick table calculations are calculated fields where we apply calculation at a data set level. Okay, not at a dimension level or anything, but we have it as a as default calculations that are applied at a dataset level. It applies to the entire table, and it depends on the table structure as well. So these are inbuilt functions where you don't need to write any formulas, and you can slice the things and compute, and you can compute entire range of the specified table structure. So let's see how quick table calculations can be used. The other day I tried showing quick table calculations, but then I realized that no, let's take it up with the other calculations. So now this time again, let me have set date. So let me pull order date to my columns, and then let me pull my sales to my rows. Okay. Now I have this value. Now let's do something. Let me Now let me, pull another sales thing over here. Okay. Now, now, quick table calculations come up with many things. Now let's see how it works. Now this sales that I brought, why did I bring it? Because I want to do some form of a calculation over here. So just go over there, put a right click, and you will see an option called quick table calculations. Now, if you see your goal, like, whatever your metric goal is, whatever your calculation goal is, you can go over here and do it. So let's see how it works. First is running total. So running total is nothing but cumulative total. And let's see what happens if I click it. So, so what happens in cumulative? Cumulative basically is, your first bar, whatever the value is, whenever you're doing a cumulative or a running total, gets added to the second, and that value gets added up to the, like, third, and then that value gets added up to your fourth. So you will always find whenever you're doing a running total, that the first value will only match, because from after that, it is aggregating the values and it is doing a plus 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 till the end of it, to show you what is the running total between these years. But sales will be like, this is basically 2019 sales, 20 sales, 21 sales, 22 sales, and addition of everything happens whenever you're doing a cumulative calculation, and you will see that this is some kind of figure that will come up, that is like running total of sales along the table, and you get this value. Any doubts? Clear?
Yes, sir.
Okay. So let me put it over here. Now let's look at the next thing. Let me pull sales again. Let me do a right click. And now what I'll do is quick table calculations difference. Okay, let me see it as a table. Let me pull it up here. So now, what is this difference? Now, difference in sales from previous year along year of order date. So if you want to understand what is happening, it's basically calculating the difference between sales along the years. So 2019 will always be a blank because we don't have a 2018 data. So what do we have? We have 2020 ka data, and what is happening? This is getting rather this is getting subtracted from this, and the value comes up. Same way, mein, these are coming up. Okay, that is difference along the line. Next, let me drag in sales again. Let me go to quick table calculations and let me do a percentage difference. Okay. Now let me pull this guy over here. And what do we find? We find percentage difference in sales from previous year along the year of date. What is the difference in sales between all these years? Okay. Again, let me pull it. Go to quick table, and let's say I want to do a rank, or no, let me do a percent of total. Now, percentage of total. Yeah. So what percentage does 2019 values of sales comprise among the entire pool of data that we have? So likewise, what you can do is, I'm not taking you through everything. Likewise, what you can do is you can go and explore the quick table calculations, and if it is something that where you get things that, oh, okay, this is already present in here, let me do it. You don't need to write a function, like separately. You don't need to write a function. and you can use this. So whatever you don't find in quick table calculations, you can very well go to the calculated field and you can write the functions over there. The next thing that we will talk of is table calculations. It is pretty similar to quick table calculations. That's called a table calculation, whereby we pull our year to columns, sales to rows. Now on sales, let me do a right click. And what we saw quick table calculations. Now let's add a table calculation, add table calculation. And what do we find in here? We find that, a drop down kind of coming up functions. So a drop down type coming up, which is named as calculation type. And then comes compute using a table across cell or specific dimensions. Okay, and it is always relative to previous, next, first, last, etc. So first, let us select over here. Like if you want to, use a table calculation. So what you did, always remember right click on the measure and then you do this. Do this table calculation. Click on the table. Let's do a running total. Okay, and when we select running total, what happens is, running total, let's select an average over here. Okay, and what happens when we do that? So when we have this, let's do an average over here. Now you have one more option which tells you run along or or however we want to run across. So when we tell run along or across, and so we can do the calculation downwards or sideways. Over here we have the data sideways, so we will do a table across over here. So how I want my calculation, so here we have it. So now what we will do is, now we see that that's a running average of the running total average of the entire data that we see. So this is basically how you do the table calculations. So in table calculations as well, you have various different types of things which you can also uh, use. So say suppose you have sales over here, so if you use a difference from, so you will see like 20 to 22 you have this difference, and then you have this, then you have this. So likewise you can explore the table calculations as well, and you can check what is happening and what is not happening. Okay, so that's about this. Now let's look at a scenario. For a company, an increase in its market share frequently translates into a higher profit margin. To ensure her company's sustainability, Jennifer, the sales manager, needs to identify growth opportunities for business and how to make the most of them. Hence, she needs to determine and study the sales variance for year over year growth based on a quarterly breakdown. Simple, na? Sales variance we need to have and a quarterly breakdown. So let's do it. So what does Jennifer want for herself? She wants to determine the sales variance year over year growth based on the quarterly breakdown, right? So what will we do? What is the first thing that will we do? We need to see a trend in sales first. So that typically tells us that we need a line graph to see, because line graph is predominantly used to see a trend. It is also called a trend line graph, right? You will see people calling it as trend line graphs. So line graph is basically used to see trends. Anyone who can guess what do we use to show share of something? Which graph do we use to show share of something? So what will you do? We have to do a time-based analysis. What are my requirements? Let me go over here. So Jennifer wants to see like year on year. So it's a time-based analysis that we need to do. We need to drill down at quarterly level. And because we want to know the difference or variance for YOY, we need to use a difference between them. Correct. So as we need year, so what we will do is we will first take year and put it to the columns, and then sales to rows. I have this line chart coming up. Okay, now I need to go at a quarterly level. Who will tell me how do I go to quarterly level? We have discussed this. That's fine, but then you can take help of drill down as well. We have seen drill down. This plus, if I do, I get the quarters, right? So what happened? So Jennifer wanted what she wanted. She wanted to have the data at a quarterly level. We are good with quarterly level. Now what is the next thing that we need to do? We need to do a percentage difference. So what will we do? We will take another sales, put it over here, right click, and where will we go? To quick table calculations. And from there, what will we do? We will do a percent difference. Okay. Now, when we do that, these graphs look like what do you call them? Like all the crooked sticks together, stuck in a particular view, and it looks very messy, right? So what will we do? What is another level of representation that we can do? We will take this sales thing, the sales pill, and let me put it to colors. Okay. Now when I put it to colors, this now makes a bit of sense as to us. Why? Because what we have done percentage of difference, and now that it was looking as messy, so what did we do? We have changed the color. So the more red it is, that does mean that it is positive in sales, and the lighter it is, it does mean that it is at a negative, right? So this is at negative, and the redder it is, that does mean that the things are like this. Now, if you have if you go to the if you hover up to the graph, you can see what is happening and what is not. So from here, if you start moving up, so you will see this difference of thing, and when you reach over here, you will see some. So here, when you were at Q1 of 2020, if you see the number percentage of difference in sales across, you will see minus, and then this you travel the entire way up, and you're almost there at Q2. Now you see a positive number coming up, and then again travel in the Q3, your number was over here, and then this. So this basically tells Jennifer what it is telling Jennifer. Firstly, quarterly wise, how my sales figures were, and what is the trend, because the redder it is, the more positive your things are. And also it is giving you the journey between the quarters along the years for this particular thing, represented by gradient coloring. So this becomes pretty easy for her to know that what is happening and how should I deal with it. Okay. Now look at another very strategic visualization, that is called box plots. Box plots are very important. Why I'm telling you, if you guys are anyone who is working, if you guys are working on data science, or if you have any interest towards data science, box plot is one of the important visual that comes into play while you're venturing towards reporting marketing. Mein box plots people avoid because firstly people don't understand box plots. I'm very sorry, but unless people are taught to see this box plot visual because box plot is a very tactical visual, and I love that visual. I'll say because a single box plot gives you the minimum value, maximum value, and interquartile values. Firstly interquartile, then it gives you median, and then it gives you minimum and maximum. So one box plot always has five different thing in a single box. Let's see how box plot works. And box plot is basically used to show distributions and compare sets of data which is highlighted up to the five key values of minimum 25% quartile, median 75% quartile, and maximum. So seeing the distribution of values along the axis, and whenever you're working with data science or data, you will see that box plot comes very handy because you have in a single view you have your entire thing which you can draw inferences from. Let's take a quick example and we will wrap up the session with box plots today because that will be very hard to grasp. And I'll urge you to go and I don't know if you guys have a license of Tableau, but then always free versions are available for 14 days or so. But then go and practice, at least practice box plots and learn box plots. It is very important in marketing, reporting, and but in data science, yes. So let me pull in some of the parameters. Let me pull in, say, what do I
Are you using a trial license or you have license?
no, yeah, I am using a free license.
Okay.
So let me pull in segment, let me pull in region, and let me pull in discount. Okay, one more thing is always have your, if you have your show me thing on, what will happen, you will see that as soon as you start putting the things, it will give you suggested graph. See, I put segment, only the table comes up. Let me pull in region.
One more doubt. In the region of visualization, in show me, you can see third last one, right? In the second row, last.
I didn't understand you. What?
In
Can you
show
be a
me,
bit?
there's a graph in second row, last one.
Second row,
La-
last one.
last section.
This one.
No, above row, last one.
Which one?
Above bubble chart.
This one.
No. Last above bubble chart, right? There is a wine cellar. We will call that wine cellar.
Looks like candle graph, I guess.
Yeah,
Yeah,
that one.
that's one.
Yeah, box and wine. So, can you explain why this graph I haven't used anywhere, but what's usage of that graph?
You're talking of this one, box
Yeah,
and whisker plot.
yeah.
That is the graph I'm talking of.
Correct now. Okay.
That is called a box plot, right? So, box and whisker plots. Yeah, that is what I'm discussing. That is what I'm trying to explain you.
Okay.
Wait,
Okay.
hold on. Fasten your seat belts. Wait. So now let me pull in discount over here. Okay. Now, why box? Now see, as soon as I have two parameters coming into play, and then one measurement to support those two parameters, see, box plot gets activated. First thing, you need to have two or more dimensions in order to, qualify for a box plotting thing. You cannot box plot with a like if you do this, that doesn't make sense. Doesn't make much sense. But always it has to be two or more dimensions qualifying this box plotting. Now let's see why and what happens over there. Now what happens? Like whenever you pull in this scenario, you will see that one bar graph will come up. Now from show me, let's go to box plot. Okay. Now what we see is an interquartile range in the box plot. Now if you go over here, what you will see something called the upper whisker, then comes upper quartile, which is called as an upper hinge, and then comes your median, then comes your lower quartile, and then comes your lower whisker. So that's the five things that we were talking of. So when we are talking about this, so basically, lower whisker is minimum. Then comes your 25% quartile. Then comes your median. Then comes your 75%, and the upper whisker is nothing but it is your upper range or the higher range. So, okay, so what happens is this basically shows you the quartiles and everything, and uh, all the things that comes between upper whisker and lower whisker, and it shows you the distribution of data along the line. So it shows you that for consumer as a segment, distribution happens like this. But where did region go? As soon as we have selected box plot, what happens is it shows this distribution from the per se of a region. It is showing the distribution of segment, right? It is showing the distribution of segment. But on what parameter? The parameter being region. On a parameter of region, what is the distribution of segment that is happening? That's why you always need two or more dimensions, because it is showing you a distribution, and distribution always comes up with uh, you know distribution always comes up with parameter which is needed along with. There cannot be a single thing. You may plot it, doesn't make sense. So what is it showing you? It is showing you distribution of segment based on the parameter of region. Correct? Now you see that region is helping it to have a distribution. Now, if I now pull back region, originally, region was not in marks. This is called marks card. Region originally was not in marks card, right? But it was from the columns. Correct? Now let me again pull it back to columns. What we see now, it shows us like now it shows us individual marks in a plot that it should but that's not how it should be. Now if I go over here, I don't see the plotting happening. Correct? Now we see that individual marks are plot, and it is not plotting a distribution that it should. Okay, clear till now? We see a flattened horizontal line box, right? And we are getting single marks, but we want a distribution. Correct? But so, as the definition says, box plot is meant to show the distribution of data. So now what we will do, we will now go ahead and disaggregate values. Why? Because now when we supply region back in there, we want this view we want this view to show up my box plot. But what is happening is, while I'm doing the segment and region, I'm putting it back in their respective things, it is not showing me the entire thing. Why? Because this metric is getting aggregated based on these two things. So what we will do, we have to disaggregate our measures. So how do you do that? You need to go to analysis, and you will see aggregate measures. From there, you need to just click this, and this will disaggregate all your measures. So now what happens in this view itself, I have my plottings happening at upper whisker, upper hinge, median, lower hinge, and lower whisker, right? To have a much more informative view, what do we do? Oh no, not this. This. What do we do? We pull in, we just rotated the graph, and what do we see? We swap the axis to have a horizontal view. Okay, now that we see that, based on my region and based on my segment, how is the thing plotted, how are things plotted, and how do we see this, and how can we take any of the inferences from it. So you can go ahead and you can change everything, you can format and stuffs you can do over here, but that is not the thing. Inference is, what is my inference? Inference is discount is pretty much same for all the segments that we have, because see, all the medians are coming in here. And what is the other thing? That central region is showing the highest range. The region central has gone beyond the 75% whisker, and its upper limit is distributed over here. And this is how we can infer that central region is showing the higher range. Discount is same for all the segments, and we can see the minimum and maximum values of the interquartile range, and we can determine for each region what is the distribution of discount from the lower level to the higher level.